we are looking at the weathering of parent materials. And weathering of parent materials can be defined as the disintegration and decomposition of rock and minerals by natural processes such as action of frost, percolation of groundwater, by frost or percolation of groundwater. And we have also established that the weathering of parent materials can take place in two forms, either by way of physical disintegration or by chemical decomposition and transformation. So the weathering of parent materials can take place in these two ways, form of physical disintegration and a form of chemical decomposition. Now, we looked at physical disintegration. We said that physical disintegration can be facilitated by freezing of absorbed water, which causes physical splitting of the material along the path towards the center, while temperature gradients within rock can cause exfoliation of shells. Now, the physical disintegration can also be caused by the changes in temperature and precipitation. When a parent material gets wet and gets dried up, it gets wet through precipitation, rainfall, and even dew. Then other forms of precipitation like snow can cause a parent material to get wet. And then the parent material dries up again as a result of increased temperature. And that's heat and wetting and drying process actually helps to break down the parent material as well. Then we also looked at rubbing of materials caused by wind, rain, and hail. When the wind blows, the wind carries along sand particles, even stones, and hit them against the parent materials. And that actually gradually over time breaks down the parent material. Even the raindrops also help to break down the parent materials. Then water, as the water flows, just as you saw during the flood, the water is able to even break down roads, to destroy roads. Okay, that's a weathering process. That's a weathering process. As the water moves, the current of the water, that's why we've not been able to resume in Amasuma even. The current of the water destroyed our road. Three very significant, very big portions of the road were destroyed. So water can also break down. Just assume that the road is that rock or the parent material. Then you understand how water can break down parent material. Just look at that in that perspective. So that's how water is even able to break down rocks and other parent materials. Even gravity can help to break down parent material. What about the activities of living organisms? As living organisms burrow into the soil, they help to break down larger particles into smaller ones. As they burrow into the soil, they break down larger particles into smaller ones. Even plant roots do the same thing. Now, we want to look at how water is able to split rocks or other parent materials. One of the properties of water is that apart from, we want to look at specific characteristics of water that enables it to break down rocks. We said that freezing of water can cause splitting of rocks. How is that possible? Now, if you look at this figure, you'll notice that you know that water is made up of oxygen and hydrogen, two molecules of oxygen 2 atoms of oxygen that are bound to an atom of oxygen. Now, steam particles have just, they are not united, they are separate, just having 2 atoms of hydrogen bound to 2 atoms of oxygen. Then water itself have hydrogen atoms bound to oxygen atoms, and they are linked to one another. Now, when water ices, it tends to expand, just as you can see at the left-hand side. It expands, and it is this expansion of the ice. What I'm trying to explain is that when it rains, the ice enters the crevices of the rocks and the water, and when it ices, the icing causes the water to expand. Now, as that water expands, it causes breakdown of the rock particles, and that's what is seen in this diagram. If you look at this diagram, you notice that here, when it rains, the rainwater enters here, this part of the rock particle, okay? And then the rock, and when the water freezes, particularly in the polar region or in parts of the world like the US and the UK during winter, when the water freezes, the freezing of the water causes expansion. It makes the water to expand. That's why ice block is floats on water. Okay, it expands. The expansion causes the breaking of the rock. Then there are other actions that also acts on this parent material or the rock. Other physical weathering processes. We also we have things like wind, just explained. As the wind blows, the pressure of the wind causes the particles, the parent material to split gradually over time. Then the wind also carries particles and that hit against the surface of the parent material. It could be sand, it could be stone, it could even be plant materials. As they hit on the surface of the parent material, they break down this parent material gradually over time. They break down the parent material gradually over time. Even rain, as the rain falls, the raindrops hit on the parent material. Hail. Hail basically means ice, ice that falls in form of rain from the sky. It's not common in this area, but it's common in the US, UK, Canada, and other countries that experience the snow or that have very extremely cold temperatures during winter. So hail also hits on the surface of these parent materials. So as this happens, including ice, it breaks down the parent material into smaller particles. Then the heating of the parent material, increase in temperature, and reduction of temperature, that is heat and cold, also causes breakdown of parent material. When the parent material is being heated, causes expansion, and when it is when the temperature reduces, it compresses. So it contracts. So the expansion and contraction of the parent material causes the breakdown of the parent material into smaller particles, causes the breakdown of the parent material into fine parent materials. So that's about physical weathering. We'll still come back to the chemical weathering, but let's look at how this it is after physical weathering has occurred that chemical weathering now takes place. After the particles have been broken down into smaller particles, then chemical weathering now takes place. Chemical weathering now takes place. And chemical weathering produces minerals and nutrients from the consolidated rocks, oxides of iron and aluminum. Then it also produced silica, silt, sand and quartz, and many other substances from the parent material. We'll come back to this diagram when we'll explain how time affects soil formation. Now we have looked at physical disintegration earlier, and the physical disintegration we said is basically caused by freezing, by changes in temperature, and it's even caused by other factors such as wind, rain, and hail, as well as water and gravity. Now we want to talk about the chemical decomposition and disintegration. I want to look at chemical decomposition and transformation, how it affects the parent material, chemical decomposition and transformation. Now, how does chemical decomposition and transformation affect soil formation? Now, what is chemical decomposition and transformation results when minerals are made soluble by water or changed in structure. Chemical decomposition and transformation results when minerals are made soluble by water or are changed in structure. Chemical decomposition and transformation of parent materials can be caused by the solution of salts in water, hydrolysis, carbonation, hydration, oxidation, and reduction. Now, these factors can cause chemical decomposition and transformation. Solution of salts in water, hydrolysis, carbonation, hydration, oxidation, and reduction. Now, what is carbonation? What is carbonation? Now, carbonation basically means when carbonic acids are formed, when water forms carbonic acids. For example, carbonic acid transforms calcite into more soluble calcium bicarbonate. So when the water causes the formation of carbonic acids, it is said to be carbonation. The reaction of carbon dioxide in solution with water forms carbonic acid. And this reaction that forms carbonic acid is what we call carbonation. Another factor, and what's the source of this water? The water that gets to the parent material that reacts with carbon dioxide is as a result of precipitation and even dew in the morning. And this dew reacts with carbon dioxide and forms carbonic acid. And this carbonic acid results in the breakdown of the parent material. Now, chemical weathering in this form produces chemical properties of the soil. Then we also have hydration. And what is hydration? Hydration basically means the inclusion of water in mineral structure. The inclusion of water in a mineral structure. And this causes the swelling of the substance, and it makes it to be more stressed and easily decomposed. Hydration basically refers to the inclusion of water in a mineral structure, which causes it to swell and makes it to be more stressed and easily decomposed. Another factor that results in chemical decomposition and disintegration is oxidation. Oxidation. And what is oxidation? Oxidation of mineral compound causes it to swell and increase its oxidation number, leaving it more easily attacked by water or carbonic acid. Oxidation, the increase in oxidation number is what we call oxidation. Increase in oxidation number. Oxidation can also mean the addition of oxygen. There are different definitions of oxidation. It can also mean addition of oxygen, but here we are looking at increase in the oxidation number of a substance, of a compound. Can cause chemical weathering. Then reduction, which is the opposite of oxidation, results in the reduction of oxidation number. Reduction in oxidation number is basically referred to as reduction, or the removal of oxygen is also referred to as reduction. But in this perspective, we are looking at the reduction of the oxidation number of a compound. The reduction of minerals leave them electrically unstable, more soluble, and internally stressed, and easily decomposed. So that's how reduction affects the materials. It makes the material or the parent material to be electrically unstable. It makes it to be electrically unstable and more soluble, internally stressed, and that makes it to be easily decomposed, easily broken down. The three of the above lists of solubility changes, and the last three are the three of the above are solubility changes. That is, we've looked at the solution of salts in water. We've also looked at hydrolysis, and we also looked at hydration. Those are solubility changes. Then the last three, we looked at oxidation and reduction. They are structural changes. They're actually structural changes. So we have looked at parent materials and how they affect soil formation. I've looked at parent materials, and we have also looked at how these parent materials affect soil formation. And we've also looked at types of soil and parent materials. We said we have cumulus parent materials, we have transported, and we have cumulus parent materials, transported parent materials, and we also have residual parent materials. And we also looked at weathering of parent materials. That parent materials are broken down through physical disintegration, and they're also broken down through chemical decomposition and disintegration. So we have looked at those two factors. Now I want to look at topography, which is another factor of soil formation. Topography. Now, topography basically refers to the how the surface of a soil is. Okay, the surface of the soil, how the surface of the soil looks like. That's what topography means. The topography, whether it is hilly or whether the soil is flat or whether the topography is steep. Now, topography basically modifies the development of soil on a local or regional scale. Topography affects the formation of soil. Topography affects the formation of soil, and basically it is affected by drainage. The topography of a soil modifies or affects soil formation as a result of drainage. When the topography is flat, the movement of water is slower. And when the topography is steep, it tends to affect the rate at which erosion takes place. And the erosion actually results in the transportation of parent materials from one point to another and affects the kind of soil that is formed in a particular area. Now, if you look at this picture, you'll notice that this topography, the topography of this soil affects the type of horizons that are formed, whether the horizons are properly formed or not, and the thickness of the horizons. Now, at the left-hand side, you will notice that at the left-hand side, you will notice that the topography is very steep. The topography is very steep, and that steep topography tends to cause erosion. It tends to cause the erosion, serious erosion at the left-hand side. And this erosion exposes the arrow horizon. And if you look critically at this, at the top of this, the left-hand side, you'll notice that the O and the A horizons are formed, and they are thicker. The O, the A, and the B horizons are thicker than those ones at the left-hand side. Okay, the left-hand side have a thicker B horizon, just as you can see. The B horizon is actually thicker. Now, because of erosion, at this point, the B horizon is actually washed off. Then at the toe slope, you'll notice that because of serious erosion, the A horizon is very thick, because the A horizon in the left-hand side and the right-hand side are washed down. You have lighter A horizon in the top of the slope than in the valley or in the toe slope. The toe slope tend to have thicker A horizon than the top of the hill or of the soil. You have thicker A horizon and water saturated B horizon. The B horizon is highly saturated by water because it is lower than this other parts of the soil. Water tends to concentrate on this area and saturate the soil. So what are we trying to say here? That topography affects the constituents of the soil and also affects the rate of erosion. And that affects the soil stratification. It affects the stratification of the soil. Topography affects the stratification of the soil. You tend to have thicker A horizons in the toe slope than on top of the slope. The A horizon is thicker in the toe slope than on top of the slope. Even in the left-hand side, you notice that the A horizon is not as thick as the one at the bottom. Then you also have a B horizon that is water saturated. So that affects the type of, that's how topography affects the type of soil as a result of erosion. So we have looked at two parent materials, two factors of soil formation. We have looked at how parent materials affect soil formation. We've also looked at how topography affects soil formation. The next factor of soil formation we want to look at is climate. And pedology. Pedology means the study of soil. In pedology, climate refers to the characteristics of weather as they evolve over time scales longer than those necessary for soil properties to develop. Climate refers to the characteristics of weather as they evolve over time scales longer than those necessary for soil properties to develop. Climate is a dominant factor in soil formation, and soils show the distinctive characteristics of climate zones in which they form. The type of climate determines the type of soil that will be formed. These characteristics include precipitation, temperature, and storm patterns. The precipitation, temperature, and storm patterns of the various climatic zones affects soil, the type of soil that is formed. So the two climatic variables that affect soil formation are temperature and moisture. The two factors of climate that affect soil formation are temperature and moisture. Now, temperature has a direct influence on the weathering of bedrock to produce mineral particles. Just as we discussed earlier, temperature causes expansion and contraction of the parent material and results in the breakdown of this parent material. It results in the breakdown of this parent materials. All right, so the temperature, the weathering of parent materials increases as a result of increased temperature. When temperature increases, weathering tends to increase more. Temperature also influences the activity of soil microorganisms. Soil microorganisms perform better in the degradation of organic matter and other substances in optimal temperatures. When they have specific temperature that determines how well they are able to break down organic. The influence and magnitude of soil chemical reactions are also affected by temperature. The frequency and magnitude of soil chemical reactions are also affected by temperature. The temperature also affects plant growth. Temperature also affects plant growth. The temperature also affects plant growth. The moisture levels in most soils are primarily controlled by addition of water via precipitation minus the loss due to evapotranspiration. So the moisture content of a soil is determined by precipitation. When rain falls, rain adds moisture to the soil. And then when it's not raining, the increase in temperature results in evapotranspiration. In additions, if additions of water from precipitation surpass losses in evapotranspiration, moisture levels in a soil tend to be high. That if additions of water from precipitation surpasses losses from evapotranspiration, moisture losses in the soil tend to be high. Why is that so? When there is higher rainfall than the number of days that sunshine occurs, it tends to increase the moisture content of the water. The moisture content of the water tends to increase because the rainfall surpasses evapotranspiration. When rainfall surpasses evapotranspiration, moisture contents tend to be high. Take, for instance, during the rainy season. During this rainy season, the soil tends to be wet because we have much more rain than sunshine. We have much more rain than sunshine, and that causes the moisture content in the soil to be higher than the moisture content, to be higher during the rainy season. But during the dry season, because of increase in evapotranspiration, evaporation and transpiration means combined to form the word evapotranspiration. Evaporation occurs when the sun hits on the surface of the soil and water particles, water it forms vapor and is evaporated to form clouds. Then we also have transpiration. Transpiration occurs in plants. Transpiration occurs in the leaves, the stomata of the leaves of plants. And it basically refers to the loss of water through the stomata of the leaves. Now, as the plants lose water and they absorb more water, it tends to reduce the moisture content of the soil. So that's basically what we are referring to. So that affects the that's one of the effects of climate on soil. Now, on a global scale, the integrated effects of climate can readily be seen along the transect from the pole to equator. Now, here is a picture that shows how climate affects soil formation. How climate affects soil formation. Now, at the equator, the soils that are formed at the equator are usually different from soils that are formed in the pole, that are in the polar region, where there is winter and other colder temperatures. You know, Nigeria is around the equator, or closer to the equator than to the pole. That's why we don't experience winter. Now, around the equator in the globe, you tend to have soils such as oxy soils, just as we have discussed. When we discuss about classification of soils, the oxy soils have rich contents of iron, and this tends to affect the color of the soil. And as you move from the equator towards the pole, you tend to see altisols. Then you also see molly soils. That's those that are in the savanna region. Around the savanna, you tend to see molly soils. Then altisols, or you tend to see altisols, arid soils in the desert area. Then you also tend to see molly soils. You know, as you move, the soils that are formed, the type of soils, are affected by the climatic condition. That's what this picture is. This figure is explaining. Okay, this is a map of Africa to illustrate the location of Nigeria. If you look at this place, you see the equator. Nigeria is closer to the equator than the pole. Nigeria is closer to the equator than the pole. So the type of soil that is formed in Nigeria is different from those that are formed in countries that are closer to the pole, the poles. It's different from soils that are formed in countries that are close to the polar region. That's basically what this picture is explaining. Now, in a local scale, that is locally, the type of soil that is formed is usually affected more by the other 4 factors of soil formation, like parent material, topography, vegetation, and time. Topography, that's vegetation means living organisms, which include vegetation, and the time. We want to look at so far we have looked at 3 factors of soil formation. We have looked at the parent materials. We've also discussed topography. We have looked at parent materials, we've looked at topography, and we've also looked at climate. So we want to look at the last 2 factors of soil formation. So the Next factor of soil formation are living organisms. Living organisms play very significant roles in soil formation. Even humans play a very significant role in soil formation. Living organisms such as earthworms and burrowing organisms such as the crabs, some rats, even snakes, they play very significant roles in soil formation. Now, how do they influence soil formation? When earthworms, organisms such as earthworms, burrow into the soil, they tend to they take in some organic matter like leaves. Even termites do the same thing. They take in leaves, and as they burrow into the soil, they also, like the earthworms, as they excrete their cast, they tend to deposit some substances in the surface of the soil, the cast.